Hello, everyone. This is Linda Westfall from the Software Excellence Academy, powered by the Westfall team. Our webinars are sponsored by the software division of ASQ. And I'm always happy to welcome Tom Gilb back as a speaker. He's been one of my gurus throughout my career. He's probably one of the first people I started learning metrics from back in the day. And he's written several, well, how many books now, Tom?
11 plus 25 digital ones.
11 books plus 25 digital ones. But what he's holding up in this picture are probably two of his first books. Again, back in the day when I first started doing metrics over 30 years ago, his book on software metrics was the only one I could even find. Now you can go find all kinds of them on Amazon.com. But back in the day, like I said, he was my guru. So today he's going to be talking about how to use Planguage for configuration management.
Okay, welcome everybody. Thanks for sharing this with me. It's my very first time holding a lecture on this subject, and I don't normally think of myself as any kind of specialist in configuration management, but I sort of naturally do it anyway, because I believe it's very important that we know how things are connected and how things change. The basis for most of this talk is my planning language in the competitive engineering book, free copy down there on the link below. And it has built in a whole lot of stuff that helps us do configuration management. Here's the list of topics I hope to get through by the top of the hour. Not to worry about it too much. On the right-hand side is sort of an overview of this mystical thing called Planguage or planning language, which is primarily a way of planning projects rather than its side is doing configuration management of the planning. So in Planguage, we have a whole lot of pre-defined terms. You're looking at a selection of them. And it turns out an awful lot of those terms, if you think about them, they clearly are looking at relationships, like dependency or stakeholder or supported by. And so this is just a list of some of the language terms which definitely try to keep track of what's going on. And when one changes, maybe the other needs to change, kind of configuration management. Here's another view of really the same thing. If we're specifying an objective or requirements and we have a core specification, exactly what we want of more security in the future, then all this other stuff here, which I call background information, is largely all about relationships of this requirement to the other entities like stakeholders and designs and architecture in the setup. Here is an example of a language specification, and for, in this case, something about user defects, and here's the core specification, the quantification idea called the scale, and then various levels of this user defects. But then we get things like authority, intended readership, owner, responsible, and implementation dependencies. So, and clearly these are relationships to that particular user defects idea. Here's another view of the same thing but in this case we're using ValPlan, an app which simply is based on the competitive engineering book and the language, and it gives digital automation. See more of that. Essentially the same thing. Now here's, which is a part of the planning. There's a whole chapter on it in the competitive engineering book, and I wrote a separate little booklet you can have for free down there at the left-hand corner. But what it's doing, it's a table that looks, which is, in other words, the ends or the G's or the lines or architecture for achieving certain requirements. And for now, it turns out that for like one G1, and we play a pretty good idea will really, give us a lot of effect. It will be effective in reaching our goal. Okay, but whether we like it or not, there will be other of our requirements which we're not very focused on, but we're going to have what engineers call side effects. Some of them good, 42%. Hey, that's nice. Oops, here's minus 42%. That's bad. That's a negative side effect. And here are some trivial effects and side effects, and even situations where we just don't have a clue as to what happens with things. And then finally, we have to account for the costs of various kinds, short-term, long-term, people, time, money, things like that. But now what the table is doing is saying take any set of designs or strategies or means and look at how they relate to any set of requirements and costs. And first thing you'll find is an awful lot of question marks or haven't got a clue. This is a way of mapping the so-called known unknowns, which I'm sure you've heard about. And known unknowns mean the result could be terrible, like minus 500% or 60 times your budget or something like that. And it could kill your whole project instantaneously, but you don't know. And so a good start is knowing that you don't know and then struggling to make an estimate, which is often crude and often plus minus 40% or something like that, and often on dubious credibility and belief. But we do actually keep track of all of that too. But I'd like to suggest this is a big configuration management idea, because configuration management is the relationship of all the designs to all the requirements, among other things. It's not just about code. There's code behind maybe many of the strategies, but we're not focused on the code, we're focused on the system. And above every coded system is a set of requirements and a set of design strategies for getting there. So if you just take away one little thing from this, maybe the configuration management tool, which I have invented, the impact estimation table, is an interesting way of keeping track of things at all different levels and all different sets of things. And you're forced into a discipline of keeping track of them numerically, which means you have to know a lot more than just putting a little plus or impacts. It's not binary. There's a big difference between 95% and 0.95%. And if you're doing serious systems, you need to know the difference. So here's another view of the table. And what we've done here automatically is we've computed the set of values to set of costs ratio, and we've picked out winners automatically, and we have sorted the winners in priority sequence, and this becomes, if you like, a queue of things to do moving into your sprints, for example, in Agile. And we can also sort the same thing exactly the same thing, but in terms of a bar chart. Okay, so this is number one in value to cost with respect to, and we can choose, but with respect to plus minus uncertainty, credibility, or just a raw score. This score, for example, doesn't take into account any uncertainties or lack of credibility, so good luck to you. But this score does. This takes into account our estimates and our plus minus uncertainty and the level of credibility of the source of information. So this is a pretty good idea to start with this one if you're feeling conservative. Here's a picture of all that. Here we have some system with its functionality. Here we have two different goals to improve, say, security and user friendliness. Here we have various strategies, A and B, which we hope will help us move toward the goal. And we try to understand what percentage of the way we get to the goal. It'd be nice to get to 1% of the goal. At the same time, we have to take a look at how these strategies impact our budget and our time to deadline. So this is just a graphical reminder of what we were looking at in the tables, but it's a way of presenting it to management and getting people to understand what's going on. Here's another diagram which is saying one way of organizing our work is to look at stakeholders to our upstream support teams and their objectives. These are not the primary customer user objectives. And then alternatively, take a look at all the other upstream stakeholders and their objectives, and then plan things and then deliver to our downstream stakeholders who are in fact the customers and users and things like that. I'm very interested in stakeholders, so I fairly recently wrote a digital book, which you can have for free, about stakeholders. I think that link is coming up, but here is what is known as the EVO cycle. Some people like to call it the Gilb cycle. My son Kai really developed it, and it's not unlike a plan, do, study, act cycle, but a little bit more detailed, like decomposition and finding solutions and learning. But it basically is plan, do, study, act. And if we start here at stakeholders, we derive their values, then we derive solutions, also known as architecture, design, strategies. Then we decompose big ones so we can do small sprints and slices. Then we develop them, meaning, for example, code them and deliver them into the real system and measure the result. And depending on whether the result is very good, very bad, or in the middle, we learn and we continue the cycle until we have delivered everything the stakeholders want, which, as Dr. Deming told me, is never as long as you're in competition. So it's an eternal cycle. There's a little paper on that I wrote last summer, share with you. Here's another view of analyzing your stakeholders, which has to be a big part of configuration management. In a large system, you have dozens, and at the extreme, depending how you look at it, maybe hundreds of individual types of stakeholders, not just individual stakeholders, but types. And some of them are not rooting for you. They're like the competitor, they're out to the enemy, and they're out to get you. And some of them will help you mitigate, like a backup facility damage. And we can analyze the stakeholders in relation to their security roles. And this is a form of configuration management. Here's something we can do when we've digitalized all of this. We can automatically draw a map of these are all values or qualities. And then here's a line going to the stakeholder transport for this one. But in the same map, we also can highlight all those stakeholders that have no requirement noted yet. And that's pretty suspicious, because if they have no requirement, they're not a stakeholder. So basically, we're looking at missing specified requirements at a glance, and they're highlighted here. Again, configuration management. Have you got at least one requirement for all powerful critical stakeholders is the interesting question. And there's the free stakeholder book down there. Go get it and get to become an expert on stakeholders. Here is an example of filling out parameters about a stakeholder. So here's the board of directors, right? And they're defined as the International Corporate Board of Directors. But then here we have all kinds of things like issues and risks and responsibilities, and which in addition also tell us about this entity in our system known as the stakeholder. They inform us. And so when we're dealing with them, we can ask, questions like, have we dealt with this dependency or not? Okay, clearly a configuration management idea. The stakeholder itself, any one stakeholder will have things like different attributes. How adaptable are they? How powerful are they? How visible are they? And so let's say easily 10 interesting characteristics of each and every stakeholder, which can, in theory, be quantified and measured. And then we have some costs. Something as simple as having a meeting means you have a cost for dealing with that stakeholder. And then there are certain strategies we might develop to manage our stakeholders, like motivating them. Take a simple example here. And this becomes a set of objects which help us understand each and every of the maybe 100 stakeholders. Again, I hope you realize this is extreme depth in stakeholders compared to anything you might have seen, or surprise me and send me something like it, because I don't know about it anywhere. And writing the book, I had to do a lot of research. Okay, so this is how to go really deep into stakeholders and their relationship to your costs, your values and qualities, and your strategies that you have to bring into your system. This is, of course, is way above the level of code configuration. Here is an example of the yellow arrow means a value that can grow and get better and better. And then here is the scale of measure defined for it. Here is a meter suggestion, how we're going to measure it. Here are a list of stakeholders, and here are the wish is the level we wish for, but we can't guarantee we can deliver it because we don't know what the strategies are to get there and what they cost, and we don't know if it's within budget or deadline. So stakeholders can wish. I have a dream, said Martin, but we cannot grant their wishes just because they are a powerful stakeholder. We have to have the resources and know how to do it. And here's another view of the stakeholder, this build constructive cooperation value, and we can see it's in a hierarchical relationship to some fundamental objectives. And actually, by clicking on this overview of the whole system, the whole configuration, we get the detail. And by clicking any one line here, like if you click the scale line, you're going to get a whole page of detail about that scale of measure. So the digital system ValPlan makes it easy to navigate a complex configuration to discuss it or change it or do anything you want. Let's see. Here's another very simple configuration management thing. If we're using the ValPlan app, then any change, even the slightest change to the slightest parameter, is automatically logged. Who done it? When did they do it? What exactly did they touch? And if you want to undo it for any reason, rectify a mistake in configuration change, you press the little undo button. So that's sort of built in. That begins to resemble conventional configuration management ideas of tracking changes and things like that. But that's just simply built into the ValPlan. Here is another way of looking at it. Here is an object, which is an objective to improve education. And here is the fact that on this date at exactly that time, Dina, who was working with me, created this whole object. So that's a version 0.0.1. So we know that that's been created, but to our knowledge hasn't actually changed yet. So again, configuration management is solidly built in to the whole thing. The thing that we're doing, which is spelled out clearly in the definition, I think I skipped that slide accidentally, of configuration management, but it's slide 2, is that we're not only dealing with resources and performance characteristics, values or qualities are almost synonyms for that, but we're dealing simultaneously with multiple values, multiple objectives, and multiple constraints. And that's tricky business. I saw something recently that a friend of mine, he had just the word the goal, and he didn't have plural. I had a little chat with him today, and I said, in any real situation, there are multiple goals, And you can't just keep track of one of them, the goal. You have to keep track of all of them and how your any changes impact all of them, as I showed you with the impact estimation table. Anyway, so this is just a reminder that it's a multiplicity of variable dimensions that we're keeping track of. Okay, here symbolically, we're moving the client accounts from 0, we have no client accounts, I guess, to 100% of what we want or something like that level. But at the same time, we can do that, but we can't blow our budget, which is at the 100% level there. Here's another very much built into competitive engineering and language because it is an agile method, as symbolized by the Evo cycle that I showed you earlier. But Elon Musk, bless him, the stock went up today after his not too disastrous interview last night with the finance people. But he stresses the importance of feedback loops. And I'm pretty fanatic on it. That, in a sense, that solves all problems of estimation and meeting estimates and stuff like that. That you have feedback loops and correction all the time, and that keeps you on track towards your goals and within your budgets. So the best risk management process is rapid feedback and adjustment of plans. Here's another view of that. These simply represent different cycles of consuming your budget, different cycles of consuming your timing, and then different cycles of delivering this one quality, okay, and then the other quality. So again, see, we have an incredibly simple model, just 2 resources, just 2 values. Reality is more like 5 resources and 10 top 10 values. And then the number of cycles is more like 50 in a year, like weekly cycles. And at places like Tesla, it's 1 cycle every day, a 10-hour meeting to improve some numeric quality during the day. Here's another view of the world I'm interested in. Here's our system, which has some built-in mitigation against security threats, but some of that was lived through and do damage. And then you have to have post-damage mitigation strategies, like your insurance kicks in or something like that. And if it only pays for $1 million of a $10 million damage, you have net damage $9 million or something like that. So, and my point here is that each of these stages can be separately managed, and you can set separate numeric objectives for each one of the quantities. Will be quantity, it will be of attack, will be detected of attacks stopped in this, and they won't have any, they won't zip through at all. Things, they're tracked, like that. And then you can ditch each one of these. This is not the code operating, this is the whole system operating in a security environment. Here's a little map of different levels. Here's coding for those who are still interested in coding. My interest has moved long ago to systems level. Code is a dominant factor. And then here are the different stages of the chart I just showed you on the previous slide. And the point is, we can go into any one of these stages and analyze it, set numeric goals for it, specify strategies, and try them out and see how it works at each one of these stages. Okay, it's advanced systems engineering with a lot of software. Software does not work without people and data. So whether you like it, software have to go to the systems engineering level to get control of what they're doing. I have about 31 slides and I'm on 25, so I think I can give early warning that we'll be able to get questions in before the hour, which is better than maybe I'm going too fast here, I don't know. Now, here's an example of planning to reduce that threat level in Planguage. Here's the blah, 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 which politicians and others love to do, and academics, lots of nice sentences with a lot of undefined terms, which sound very nice. But in my world, we say, okay, we've taken note of your blah, 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 but let's get very concrete about it. What scale of measure? What does it mean, degree of threat reduction? And so here's a scale of measure. And then how bad is it up to now, the past level? How good do we want to be in the future, goal level? What's the minimum we have to do to stay in business, even though we don't yet reach our longer term goal of 90%? And what constraints do we have to respect when dealing with this, like privacy laws, GDPRS, and what potential strategies are people thinking about, but we haven't yet in detail estimated their costs, their risks, their side effects, and things like that. So that's a later stage. And here is another one of the same thing, except in this case, I've brought in some language parameters. One called which is like the Guinness record best. So we know it's technically possible for some, like our best competitor, but maybe not for us. Maybe we've even got to be better than our best competitor. And trend also says if things keep on going the way they're going, we're going downwards and out, and our best competitor is going upwards and going to thrash us. So this helps us reason about the minimum, the tolerable goal, and the actual real ambition level or goal that we want and who did it. So notice that every one of these parameters is an element in a configuration. I mean, this is the configuration of the record holders. This is a configuration for the future. This is our planned configuration for our future. So it's all elements of understanding how requirements and design and code and things like that fit together. I'm pretty fanatic on everything being well defined. I hate it when I see a sentence with 10 undefined terms coming from the CEO or a top politician. I just say, what a waste of time. But so Planguage has a lot of things predefined, like that word scale or the word goal has very formal definitions in a 700-word publicly available glossary. You'll find part of that glossary in the competitive engineering book I mentioned at the beginning. But then as we go along, as we develop concepts for innocent words like a word active or a word acceptance, we define them and then we hit a little button saying, make this definition formal and the only one in our project gallery. So when we use this term again, it will automatically retrieve the current updated definition and use it. And in this way, you get consistency of terminology or concepts and of definitions throughout a project or an organization. This is built into ValPlan to capture the glossary and exactly who changed it and when, etc., or who created it. Here are some examples of some of these things that pop up. We wanted a scale of measure for building constructive cooperation, and the blah, blah, blah level was build constructive cooperation for Druze and Israel and Palestinian nationality. This is back in the days when I worked on peace initiatives for the Middle East, which haven't worked yet, but we're going to have to get back to them. They're about breaking bread with enemies. And anyway, that sounds nice, but what about a scale of measure for constructive cooperation? And so here's what we came up with. We worked 2 years building this model. That's the percentage of the religions, nationalities, and ethnicities that view, whatever that means, connect, whatever that means, engage. The capital letter says this is a defined term. And the square brackets say we're going to have to tell you exactly what we mean. For example, when we use the word sustainable here in the status, it means it's the parameter is the continuous parameter, whatever that is. We'll show you more later. So this is a highly structured scale of measure but it's a highly complex thing in the Middle East, as we all know now, if we didn't know that before. And here's an example that the wish level of 42 is for the Druze religion, for the set of nationalities, Israel and Palestinian, for all ethnicities, et cetera, et cetera, et cetera. So we're able to define in a very complex system with thousands of possible combinations exactly the configuration that we're looking at when we say by September 2023 we'll get from our of 10 better to 40. Okay, it makes precise statements possible and precise analysis of our configuration, in this case, requirements and progress of our project possible. Here's a deeper view of this scale of measure, which then so here's the parameter in the scale at the top, and parameter here parameter scale up here effectively set that are interesting. In a sense, a combination of one or more of any of these become a configuration definition.
Tom, okay? Can you repeat
here we have
the
a
last paragraph or so? You were breaking up terribly.
Oh dear. Okay, for this slide or for the previous slide?
The previous slide. That last paragraph or so, you just you were breaking up terribly.
Right. Okay. What we're looking at here is a scale of for building constructive cooperation. Now, that sounds like a nice idea, but how would you quantify that? And so what we do is we take the what I call bullshit level, the one stated by the politicians. Sounds nice. Using that as a point, we for a scale of measure, the percentage of all these different entities and different combinations. And now we have a precise language for looking at a very detailed, but perhaps very critical part of the configuration. And here's a look at that, a scale of measure here, percentage success level in these areas. And then each of these areas, like shocks, is defined as either a climate shock or an economic shock or a social shock or environmental shock. And we can even have subsets of that, which define environmental as flood, fire, etc. So the point is this scale of measure with parameters gives us a tool for detailing real and complex configurations of systems we can pick out the combinations that are most critical, most interesting, deal with them early, prioritize them early. So it's an agile decomposition technique, for finding agile slices that we deal with, maybe economic power and recovering and weak health and etc. We can pick out a very detailed configuration, but still that may be 50% of our entire problem. And if we can do that in an early phase of our project and get results back, well, we're delivering extremely high value for extremely low project time. Okay, so this is a very, very advanced agile method. Do you think I dealt with the last 15?
Yeah, we're good.
Last minutes? Okay, good. We're almost ended there. Now, in addition, part of our configuration is all of our processes and standards. So here's an example of a process published in the competitive engineering book for requirement specification. And it refers to other things like generic entry conditions. And we've pulled this into the digital tool so it's available at all times. And so we can navigate around all of the different standards while we're working on doing them in practice. Again, this is, in other words, part of our configuration management system is the configuration management of all known processes and all other standards. Finally, I think here's another thing. Here, this is a chart from ValPlan. These bars here represent different objectives in future time. And as we get feedback from early steps, we plot them on the chart. So this is the past, this is probably right now. And we can see things like at this rate, we're never going to reach the July goal, which is about 5 times higher than, we're not going to suddenly go up there. So we better start worrying here. Okay, so this is keeping track of how are we doing in delivery of value or anything else like cost eating up the budget and eating up the time to deadline, and how are we doing compared to our objectives or our resources. So this is built in and part of the picture. Future perspectives, long story short, there are 3 things going on here I'd like to point out with this slide. Number 1, if you have a well-developed language for systems engineering like Planguage, then you have a basis for better configuration management than you had if you don't have such a language. By the way, the good news is Planguage is free. You can have it, you can modify it, you can use it, no license, nothing. Okay, so that's a pretty good deal. If you find a better language, let me know. I'd like to tell people about it instead of telling them about the best I know up to now, which is Planguage. Now, I designed Planguage so that it was computer tractable, so that a computer could understand it and do things with it that you've been looking at. You know, for example, this. So not surprisingly, about 2014, my good friend Richard Smith in England said, just for fun on the side, I'm going to build a tool called ValPlan today, which automates all of Tom's ideas in competitive engineering. And I love the tool. I wouldn't want to do anything without it. It's like I wouldn't want to write a novel without a word processor, although some might argue that a quill pen will slow you down and make you think more. But I prefer automation wherever we can get it. So in other words, a well-defined and comprehensive language can give you a configuration management tool, which is not just manual, because we had that for many years, but is automated and has the advantages of automation of keeping track of every little detail and nothing can be forgotten kind of situation. And with AI, we're moving into areas we're not quite there yet. One of the things you'll find, by the way, if you ask your favorite AI tool to do something in Planguage, like give me scales of measure for 10 security objectives, it will do it. It knows about Planguage, and it will do it better than any of my human students. So it'll even build up these impact estimation tables and suggest levels of competence. So the AI systems are already superior to most every human I know in planning systems. And of course, help us with configuring. We're almost there. My son, Kai, he has an investor working on if you like, an extremely advanced database tool, graphmetrics.com. Behind it are people, Tim Byrne, the new internet standard called Solid for security, and we're gonna put all this stuff in there. So it's going to be even better than we could do the last 5 years. We're going to have incredibly smart systems, and we can just say, go forth and check the configuration and tell me if I have any problems. Hopefully, we'll see. So last slide, and 15 minutes in hand. Wonderful. So please start writing your questions in the question area here. I'm retired. I'm not after your money. I'm not selling any services. I'm not selling the books. We'll take money for them, but you can have them for free. And if you want to argue with me or ask more questions, there's my private email. And I love to talk to people. That's my hobby in retirement. There are a couple places where you'll find. I mentioned 25 books. The last 5 or 6 years, I've written approximately five digital books every year. And if you think I'm joking, go here and take a look, or here. And it's just easier. I'd rather write a book than spend time with the publisher and editing it to get it out. Because once it's digital, I can give it to you. Everybody can have it, and I love that. So there's the guy who built the tool I've been talking about, and how to get free trials on it and have a bit of fun. Your own configuration management tool. Okay, so I'm done, and I'm ready for questions, if any.
Okay, thank you, Tom. Let me take back the presentation. And finally, let's go to the questions. Here's my contact information. It's always in the slides. And there's also Tom's contact information, which is will be in the slide set as well. He's also given you in the last of his slides contacts to a lot of this information. So Roxana asks, Tom, in my industry, these stakeholder attributes are defined as types of requirements, e.g., quality functional, non-functional requirements, etc. Why should I still identify stakeholders in this case?
Okay, now, in general, a stakeholder is by definition an entity, not necessarily a human one. It could be European law, right? An entity which has some requirements that we have to probably respect. They can be more or less powerful. Not only that, but once you have a stakeholder out there, you can ask, in addition to that first requirement we know they have, do they have any others we need to heed? In other words, a stakeholder can have one or more requirements. Now, one of those additional extra requirements might not be in the setup that you just described, which seems to proscribe a limited number of requirements from a limited defined number of stakeholders. So you risk failing to see a requirement which might hurt you. It might only steal 10% of your budget, but it might not destroy everything. But long story short, the answer is you want to, if you have a large complex system and you want to be thorough in analyzing your risks early, you will, no matter what your corporate standard is, systematically analyze all the stakeholders. Then you'll look at their requirements. Then you'll decide which requirements your project has to obey or deal with. Okay, and which ones you can afford to ignore. That's the now longer answer to the question. Please pick up my free stakeholder engineering book mentioned in the slides here, or email me to get a copy of it.
I can give you an example from early in my career. I was working with an energy park where they had a whole bunch of buildings with one electric bill, and then they had all kinds of parameters for slicing and dicing that bill and allocating it to various tenants. And I worked with the primary stakeholders. I knew who they were, built the system, installed it over the weekend, and started entering data. And everything was doing good until we hit the American Red Cross. And my primary stakeholder, my customer, pointed to the screen and said, "Where's the field to make American Red Cross sales tax exempt?" And my first reaction is, "You never told me that was a requirement." My second reaction was, well, if I knew you had that tenant, if I'd have thought of charities as a stakeholder, I wouldn't have missed it. So if you don't identify your stakeholders, you may miss key essential requirements.
Good, thank you.
Barbara Armstrong asks, where did the term Planguage come from? Is it a GitHub term?
No, I invented it sometime in the last century. It means it's short for planning language. Planning language. Okay, and it's just a concatenation I made for fun, and it stuck as a way of defining the language I have developed that you can all have for free.
Okay, the next question, how do we address the complexities of using multiple tools that are not communicating with each other?
Oh my gosh. Interesting question. I haven't ever dealt with that directly, but the methods for dealing with it are there. Let's set up our 5 most critical values for project management. Let's call them reliability and timeliness and ease of use and things like that, okay, on an impact estimation table. Then let's take those tools you mentioned on the top row, tool 1, tool 2, tool 3, and try to understand, for example, if one tool is very unreliable or very unstable or very difficult to learn. Long story short, an impact estimation table, even crudely and simply done, would give you some insight that you can present to others and say, that's why we're not using this tool, even though it's very good in aspect or okay. So for short, I think I would try to analyze it using an impact estimation table. If you want some help in actually doing that, and you feed me of the tools and a list of your main concerns for the fun.
Repeat that last sentence, you broke up.
Sorry, it was Barbara who asked the question.
No, this one was Roxana.
I'm sorry, Roxanne. If you want some help in set an impact estimate to analyze the different tools, why their combination, please to do it with you by email on the side or something like that. So just email me. But you can have a go at it yourself and then say, this is as far as I got. Tom, I don't know how to define usability of the tools. I'll help you.
Okay, Roxanne asks a lot of questions. What is the difference between Planguage and project management?
Okay, now project management has many different definitions. Let's pick one from the project management institute, sort of standardize on it. Now, Planguage is a language primarily for looking at things like requirements and design and stakeholders and functions and constraints, that area there. So it's not looking at code, number one. It's, everything to do with code is sort of outside of that vision. It's a systems engineering method, Planguage. Like code, is designed to be interpreted to a degree by computers. So you can think of it as a very high level compiler, and no doubt using artificial intelligence, it will be used to generate whole systems based on high level descriptions. You can already see that today. I've got examples of it I'll share with other people, where the Chat GPT 3.5, the free one, knows exactly how to configure everything and all the details about them. It's quite mind-blowing what's there. So there may be elements of project management which are not in Planguage. I can't offhand think of them, but somebody might think of them, although might be wonderful, and I might have regarded them as extreme now. and it's agile, and it's engineering. So language, it's all I've ever needed to to manage projects, and I've taught it to like whole organizations like Hewlett Packard, and Boeing and Intel use language massively for decades on all kinds of projects. And there are very few modifications or additions. They've got what they need there largely. But there will always be something we need that falls outside the scope of this. So, and now the thing is, you can then add to Planguage, for example, an additional component for artificial intelligence, just to think of something. And you can add to Planguage anything you like, any way you like it, anytime you like, and I'm not going to bother you. So it's designed to be extendable or scalable to anything in project management. But it is essentially a project management tool.
Ben says, I saw a slide on risk management and wondered if you have any books that focus specifically on that topic, especially in the light of Planguage.
Right. Okay. Now, number one, if you go back to that slide when you get a hold of them, you'll find there is a reference to a chapter in a book I have on LeanPub called Value Planning. And it's a whole 60-page chapter on risk. Okay, so if 60 pages of my opinions about risk are enough starter, you have a link in the slides already. If you're impatient with that, send me an email, say, send me all your risk stuff, Tom. I'll be very happy to do it. Now, I have a belief that every little detail in Planguage, let's just say there are 100 details in Planguage, like the tag for an object, the scale of measure, the parameters, these are all details. Every little detail represents both a risk, like you don't do it or you don't do it well and things go wrong, or an opportunity, do it well and you reduce the risk things will go wrong. As far as I'm concerned, it's one gigantic way of dealing with risk, because I believe risk is in every keystroke, every pen stroke, every detail. It's integrated with everything else. It's not a specialist subject, and it's not as narrow as some would have it.
I totally agree with that statement. I actually have talks on risk-based peer reviews and risk-based configuration management and risk-based testing and risk-based everything else. Because you've got to always be thinking.
Feel free to add them to this talk. Good stuff.
Okay. Roxana also asked, who should drive all of these planning steps? The CXOs and executive management, or the projects?
Okay, and the answer is all of the above, but at different levels. So, for example, the C-suite generally, probably for a project, should be limited to discussions about the top 10 major improvements or value objectives, we call these. And they should also have a say in the resource constraints, i.e. budget, deadline, people that they're willing to spend to achieve those. And that's all on one page in Planguage. Okay, the top 10 goals and the top 5 constraints. Even a CEO should probably look at a collection of projects of that nature rather than any one project, unless that project is a major one for the corporation. Now, the CTO, technical, is responsible for the whole idea of deciding to adopt Planguage or not, deciding how rigorously the teams will deal with their projects. If you have a trivial project that any coder can code in 3 days and you're done, you don't need Planguage. But if you're developing a system for, say, the air traffic control system or the United Nations sustainability goals, then you need Planguage to express the real complexity that's in all of these large and complex systems. And if you do not use Planguage, you will fail predictably because you haven't even clarified your goals, let alone iteratively measured that you are meeting your goals in an agile process. I'm not sure I answered the question, but I tried.
And my answer again is risk-based. If you've got a risky project, you need it. If you have a less risky project, it's probably overkill.
Yes, of course.
And one last question. How do you prove that standards were followed to implement requirements?
Okay, well, the answer is inspections. And so inspections basically look at code or requirements or design with respect to the standards for the code, requirements, or design. Okay, so a defect when you're looking through requirements, a major defect is a violation of a standard that says how the, for example, if the standard says all qualities will be quantified, and the quality requirement says simply much improved user friendliness. Well, then you have a major defect because it violates the standard of quantification, which is designed to force people to be more specific and clear.
Okay, and that's the end of the questions. I'm getting comments that are coming in. Wonderful and inspiring presentation. Thank you, Tom and Linda. Roxanne says, this was great. Thank you. Monica says, thank you very much for another great and useful presentation. Here's one. Inspections are very human dependent. Is this a risk?
I didn't hear the first, something about tune. Please repeat.
Inspections are very human dependent. Is this a risk?
Yes. Yes, and for that reason, we have for decades always tried to perform inspections as automatically as possible. So many things can be checked automatically against rules, but many things cannot. So I've always said that that which we cannot yet check using computers or artificial intelligence has to be checked by humans if we want to check it at all.
And that means the humans need to be trained to do it well. With feedback loops.
The best yeah. But the best training of inspectors is practical training rather than, we have for years held 1 week courses training the moderators to lead the inspections. But even that, we've simplified the inspections and reduced the training needs to virtually zero. And that's called specification quality control, my new name for inspection. But that's in the books. It's in the, look in the free competitive engineering book under the chapter specification quality control. That's where we have a simplification of the IBM Fagan inspections that radically reduces the costs of training and doing.
Yeah, nothing like on-the-job experience. Well, again, more thank yous, more helpful discussions. That's the last of the questions, Tom. Do you have any final comments before we close down?
Feel free to email me and harass me and object. I love to talk to you.
And Tom, would you please send me a copy of your slides so that I can include them with the recording?
Okay, I did already today send you links, and so if you don't have them, shout. It ended up in your junk mailbox, but I did send the link. And the link, it's on the first page of the slide. Yeah, you should have it, but if you don't, just shout, please.
I've been busy working on my book all morning. I haven't checked emails since 7 a.m.
I know.
So
I knew you hadn't. Okay.
I'm sure I have it. Thank you very much, Tom. Yeah. We hope to hear from you again in the near future. And with that, I hope to see all of you next week when we're going to start talking about various presentations on and webinars on data. Thank you all very much and have a great week, everyone.
And I look to joining your other session.
And we're done.
Okay. Down to 31 attendees. There were over 51 attendees, which
Yeah.
is good.
Yeah, you had to always have good representation. I think there was
Good to
over
know.
90 people who signed up for it, but a lot of them do that so they get the
Right.
announcement about the recording.
Right. Okay. As long as
Thank you,
people are
Tom.
listening, then we'll see if people are doing. My pleasure. Go back to your book.
Yeah, I'm
See you
proofreading. You were
later.
talking about the editor. I'm proofreading the edited copies.
Right. Oh, by the way, I hope you know that I have sent in 2 suggestions for possible lectures to
Oh,
you. And if you didn't receive them, tell me and I'll send them again. This
yeah, would you
happened with this
resend them?
lecture too.
Because
But
I don't remember seeing them.
oh, oh dear. Okay. Check your junk mail, but I'll resend it.
I don't do
And I'll
junk
send
mail.
a
I've
copy to
deleted
Rob.
my junk folder and look at everything, but sometimes I'll hit the delete key too
Ah,
fast.
I'll tell you what, as a backup, I'll send a copy to Robin in case he gets it.
Okay, great. Thank you.
Bye bye.
Bye.